And of course, nobody would be satisfied with a discussion of the solar system without giving a little bit of attention to poor Pluto. So Pluto is essentially a Kuiper belt object, and the Kuiper belt is understood to be the region in the solar system beyond Neptune's orbit, where the gravitational interplay of Saturn primarily flung these planetesimals out beyond Neptune's orbit. Now, Pluto could have been one of them, or it could have significantly formed by accretion within the belt itself, but nevertheless, it's treated a little bit separately, and we'll understand that shortly. But Kuiper belt objects, KBOs, most of them tend to be ice-rich comet nuclei. I mean, what's a comet? It's a mixture of the volatiles and rocky material. It's a mixture. Makes sense. They are out beyond the snow line. This belt exists from about 30 to 50 astronomical units from the Sun. Again, 30 to 50 times the Earth-Sun distance. Now, Pluto is a Kuiper belt object, and just as we discussed how Saturn and Jupiter are in a 1-2 orbital resonance, Pluto is in a 2-3 resonance with Neptune, meaning for every 3 orbits of Neptune, Pluto orbits twice. And again, a resonance is something that tends to amplify or perpetuate itself, kind of like a kid swinging on a swing. You give a little bit of push just at the right time and it amplifies the swing. You're pushing with a period equal to the resonant interval, the natural resonant frequency, so to speak, to amplify that swing. You wouldn't push at a slightly different time, it would wipe it out completely. So this resonance, an object like this with a resonance, a 2-3 resonance with Neptune, is called a Plutino. It's called a Plutino because Pluto is the quintessential object that has that particular characteristics. Turns out there's thousands of Plutinos. Surprise, surprise. So a lot of the Kuiper belt objects have this resonance. Now anything beyond Neptune's orbit is just considered a trans-Neptunian object. Makes sense. Trans beyond Neptune. And so those are designated as TNOs, trans-Neptunian objects. And then a TNO that sphericizes, I don't know if you can find that in the dictionary, but that's a term I use, and the spelling I associate with it, but a TNO that sphericizes, meaning that it's got enough mass to form a sphere from its own self-gravity. They're called Plutoids, because Pluto happens to be, again, an object that has done that. So Pluto is not only a KBO, a Kuiper belt object, it's a Plutino, and Pluto is also a Plutoid. So they all kind of merge together mainly. But hopefully you can see the distinctions. So we got Plutinos and we got Plutoids. Pluto's being the first member of those categories. So what's beyond the Kuiper belt? Well, the Kuiper belt, all the way out to 50 astronomical units, contains an estimated 200 million comet nuclei, which every now and then when they get sent to the inner solar system through gravitational interactions, they will reveal themselves by basically vaporizing because they're within the snow line and the sun starts to vaporize them, and that is revealed by the gases coming out and having sunlight reflect off of them. So they're very pretty objects. Well, way beyond that is the Oort cloud, out to 50,000 astronomical units. So the Kuiper belt's pretty impressive being so far out there. And this diagram does not do justice to the scale, but if we can see imagine the solar system of planets here, and in this region, blowing this up, the Kuiper belt, the Oort cloud is way beyond. But as you can see, 50,000 compared to 50, this Oort cloud is as much as 1,000 times the extent of the Kuiper belt. So really, really large. In fact, so far out, in the order of a light year, that it's very tenuously, very barely gravitationally bound to the sun. So not much is understood about that, but evidence for it existing is pretty strong. with evidence of long period comets coming into our solar system. Well, you've probably all heard about the asteroid belt, so what's that? Well, that's a relatively inner solar system relic that has been seriously altered by Jupiter. Consists of millions of little planetesimals between Mars and Jupiter. Now these, when you see images like this, graphics I should say, it leads you to believe that maybe the asteroid belt with these millions of objects has more mass than the rest of the solar system or something like that. It turns out that's not at all true. It's deceptive and trying to show a graphic to depict this. The total mass is about 5% the mass of the moon. Now the moon's mass is about 1/80th the mass of Earth. So that seems very paltry in comparison to anything we've been talking about. Nevertheless, it's significant because there are millions of still significant sized bodies, many of which if they slammed into Earth they would do serious trouble. What's in the asteroid belt? Well, it contains asteroids, which are smaller than planetesimals as far as the word designations. We have meteoroids, which are preceding meteors. Meteor is something that comes into the atmosphere and then a meteorite smacks into the Earth. But the meteoroids are smaller than the asteroids. And then comets also, which are a mix of volatiles and minerals. So that's the constituents. Some of the largest asteroid belt objects. In comparison with Mars, here's an image, and so here's some of the very big ones. So we see Mars here, and here's Ceres, Vesta. These are really large objects. And we have Ida, Eros, and Gaspra in comparison to Mars. Mars is quite a bit smaller than Earth, but nevertheless, some of these objects are really, really big. And interestingly, Gaspra, turns out, we sent a spacecraft close to it and took some high-resolution images of this 12-mile-long object. Can you imagine that? That'd be a pretty good jog running across that thing. So there's an interesting view of it. We have another interesting view here of Ida. So here's Ida, and a slightly different angle as it rotates around, but it turns out that Ida has its own little moon, Dactyl. There it is. And that's essentially the distance. This little moonlet is orbiting this asteroid, and there's a closer in view. So isn't that something? We actually have asteroids with their own moons. So that's the asteroid belt. The Late Heavy Bombardment. Sounds like a perfect title to a new teenage video game. Well, the solar system has been bombarded throughout its history. Certainly more so early on than later. Right now, if we were bombarded like it was earlier, all the planetesimals ripping around, the asteroids, so much of that has been cleared out and cleaned up because of especially the gas giants. But there was a period of time where the bombardment or the impacts increased in frequency quite a bit. So it was late in the process. So we had Earth being pelted like crazy from things that were out there that could wreak havoc on Earth and the moon as well. This whole process took place about 4.1 to 3.8 billion years in the past. Giga-year. G-year is billions of years. So at that time, there was so much impacting going on the Earth and the moon, for instance. The moon's evidence is still there. The Earth is, because through erosion, weathering, the evidence of the impacts has essentially been erased. But during that interval of time in history, there was an exceptional amount of this impacting going on. Well, we already actually set the stage for why. If you remember, as Saturn was migrating out and flung out Neptune and Uranus, the ice giants and the gas giant Saturn caused so many planetesimals to be thrown out as well, and some were thrown inward, entering the asteroid belt, stirring up the asteroid belt, and actually crisscrossing the inner planets and impacting them. So the solar system was essentially stirred up by these gas and ice giants and their gravitational interplay with the planetesimals that were left during that era of time. So that resulted in tremendous beatings of the Earth and the Moon and the other inner planets by these planetesimals. And the whole mayhem was over at the end of about 3.8 billion years, and everything has subsided substantially since then, thankfully, because that has significant implications for the sustaining of life, and especially advanced life. And I thought I'd throw this picture in here also. Well, it's not, truly a picture, but it's a little bit out of place because the Earth was not that evolved during the late heavy bombardment, but it's a pretty cool image of a large asteroid hitting Earth. Something that size hit us now, that would essentially probably wipe out all advanced life on the face of the Earth because of the subsequent effects produced by such an impact. Well, I mentioned I'd talk about the formation of the Moon, and it's been a thorny issue for scientists to understand how did the Moon form. The simplest theories, like forming with the swirling debris disk around the sun that formed Earth, you'd think the Moon would have formed along with that, but it couldn't because it was way too close to Earth, much closer than it is currently, and Earth would have literally tore it apart. So the impactor theory is the one that stands as the only viable theory to account for the Moon. And an object about twice the mass of Mars, recent simulations and evidence has focused on a body of that mass, seems to be the right culprit, that hit the Earth at just the right angle and speed, literally destroying the object and destroying the Earth in the process too, essentially. I mean, Earth is reset. Any oceans or atmosphere that Earth might have had are absolutely gone, and everything starts over for Earth. It changes the constituency of Earth too, and seeded it with more heavy elements that subsequently, to this day, throughout the eons of time, have contributed to tectonic plate movement, and that has significant implications for the oceans and the land masses, basically the things that are necessary for the support of advanced life. So we should be thankful for the way the Moon was formed. Without it, the Earth would be a complete different place. Well, the part of this collider that did not merge with the Earth sent a debris disk around the Earth that coalesced into the Moon. And over 1,000 years or so, the Moon actually clears up that ring around the Earth and becomes the Moon as we know it today, which over the billions of years has spiraled outward many times its original distance. So that's the current state of our understanding of the formation of the Moon. And now let's watch a video animation of how the late heavy bombardment impacted the evolution of the Moon. Well, that was a pretty good visualization of how the late heavy bombardment influenced the development of the moon. Very significantly, I might add. Lastly, let's consider how a planet is defined. What does it take to be a planet? Well, what it takes is three things, as currently defined. Namely, the object must orbit the sun. Okay, yes. And they can't orbit a planet, because that would be a moon, right? Secondly, it has to have enough mass to sphericize. That's pretty much anything about 1,500 miles or so in diameter. Has enough self-gravity to form itself into a spherical shape. And thirdly, has to have enough gravity to clear its neighborhood. Like Jupiter, when it gathered the gas in its path and sent the other gas inwards and outwards, flinging it all over the place, clearing a wide swath in its wake. Well, the first two conditions here are the conditions needed to produce what's called a dwarf planet. And Pluto meets that condition, those two conditions. It orbits the sun, has enough mass to sphericize, but it doesn't clear its neighborhood. Now, there are other objects that have been designated as dwarf planets, and here's a summary of them. In comparison to Luna, the moon, which is not a dwarf planet because it's a moon, it orbits Earth, as Earth orbits the sun. But Ceres in the asteroid belt, we've seen already, Eris, Makemake, Haumea, and Pluto are officially dwarf planets, and there's probably a lot more out there that will be identified as such in subsequent times and discoveries. The key thing is that you have to be able to clear the neighborhood that you're in. And so here's a visualization of that. The major planets have all cleared out their surrounding region of dust and gas. Of course, you see the asteroid belt here, but there's no planet in that region. So Pluto has not been able to do that. It has a different history, a significantly different history than the actual major planets. So technically, it's a good decision, a right decision in my opinion, but nevertheless, poor Pluto. This is proof that size really does matter. So Pluto is out of here. And that will conclude our brief discussion and overview of the formation of the solar system.